So section 2.3 is going to go over some more facets about a function, increasing and decreasing, domain and range. We're going to start out with example A here, which gives you the graph of something that kind of looks like a polynomial. Let's take a better look at it here. Let's start with the domain. Domain is associated with which coordinate? The x coordinate. Good. So the domain in this one, let's get at it this way. The domain starts out as everything, and then you start throwing out things. You start throwing out things like where the function could have a 0 in the denominator, or where the function could have a negative underneath the square root. So those are the kinds of points that get thrown out. But are we going to run into any of those kind of points with this graph, assuming it's a polynomial? Not really. So kind of looks like the graph has a domain of negative infinity to infinity. So the domain here would be negative infinity to infinity. Does anyone remember that fancy notation that I liked for this?
R.
Yeah, the script R. Yeah, all real numbers. So that's kind of nice that you remember that. Good job. Our range, well, our range is associated with the y values. So the range is going to go from lowest to highest. In terms of our y values, what's the lowest? Yeah, negative infinity. But how about the highest? It's no longer negative infinity to infinity. That's a 7. Now the good question there on the 7 is, are we going to use a bracket or a parenthesis? Does it actually get up to 7? Is there a point here on this graph at 7? Kind of looks like there is. So assuming that there is a point there at 7, should I be using a bracket or a parenthesis? Bracket, because you want to include that point. So it's going to be your 7. Now before I go back and work on increasing and decreasing, I want to do that with a simpler function. So we'll come back to this one in just a second. But let's take a look down here at example B. And again, look at the domain and range. This time it's going to be a little bit more finite. So here's a better look at example B. So for example B, let's start out with the domain. What's the domain of this graph?
Negative 3 and 4.
Good, negative 3 to 4. It's just where the graph lies in the x direction. So the domain is negative 3 to 4. How about the range?
0 to 5.
Yeah, nice. 0 to 5. So we're talking about things in the y direction. And in the y direction, this graph goes all the way up to and including 5. So 0 to 5 is your range. And let's see, let's get rid of that so we don't be too confusing. So that's what we got so far. But another aspect of functions that we're going to look at, somewhat in this class, much more in calculus, is where is this function increasing and where is it decreasing? So let's take a look at it where it's increasing. Now when you talk about a function and where it's increasing or decreasing, you're going to talk about it in intervals along the x-axis. I don't want y coordinates at all as part of your answer here. I just want the x coordinates. So looking at this, what's the function do after it starts?
Decreases.
It's decreasing. So it's decreasing from negative 3 to 0. And then it starts increasing from, I'll let you look at that for a second. But as far as decreasing, because we've got a nice solid dot at this point, we're going to use a bracket. Now this is something that, I would change if I was the authors of WebAssign, but I'm not. So it's going to decrease from negative 3 to 0. But let's be careful at 0. Oh, excuse me, decreasing. Yeah, decreasing. Thank you. Decreasing. But let's be careful in another sense, not just the fact that I put it in the wrong spot. And thank you. But let's be careful about the bracket or parenthesis, -3 to 0. At 0, it's not decreasing, nor is it increasing. 0 is kind of this strange point in between, this no man's land. For just a moment, the function is flat. When you get to calculus, we'll say that it has a horizontal tangent line, but that's above our pay grade right now. We're just not going to include the 0. It's not decreasing, nor is it increasing at that point. So if we're not going to include the 0, then what should I be putting to the right of 0? Parentheses. Good. So it's decreasing there, and then starts increasing. So it starts increasing at 0. So I'll put a 0 here. And it's going to keep on increasing until we get to what point? 3. Now, if you said 5, I'm sympathetic to that because it is increasing until 5, but 5 is the y value, all right? And I don't want y values at all as part of your answer here. If you gave 0 to 5 as your answer in WebAssign, it would mark it wrong. Also giving me the 0.00 to 3 and 5. Not really crazy about that one either. Just give me answers in terms of the x-axis. So 0 to 3. Bracket or parenthesis? Parenthesis, good. Because at 3, you have this brief pause while the function flattens out and then comes back down. So 0 to 3. Then what happens to the function? Starts decreasing again. So that last interval is going to be 3 to 4. So union 3 to 4. And 4, at least WebAssign is going to put it in a bracket. Okay, so it's just the endpoints that you have to worry about for brackets. All this other stuff in between is going to be parentheses. Nice, nice. Okay. Let's go back and take a look at example A and fill in the rest of the details there for example A. So let me come back up here. We want to do the same thing. We want to find out where is it increasing and where is it decreasing. Now, presumably, this function continues on and on and on forever, down and to the left, and then down and to the right. So eventually, it's going to pass through everything to the left and everything to the right. But in between, we got to decide, well, where is it increasing and where is it decreasing? So looking at the function, in this yellow part of it, it's increasing. It's increasing, increasing, increasing until you get to this point. So that point is as high as the graph gets, and it's increasing until it gets to that point. Now, when you're talking about increasing and decreasing, it's going to be reported in intervals. It's going to be your left-hand endpoint to your right-hand endpoint. So what's that going to look like in terms of our interval notation?
Negative infinity.
Negative infinity to 2. Nice. And both of those are going to get parentheses. Plus and minus infinity always get parentheses. And the 2 is going to get a parentheses. So what happens after it gets to 2? Starts decreasing. So it's going to start decreasing from 2 parentheses until we get to where? 4. So look back at the graph here. When we get down to 4, yeah, the graph starts coming up. So 2 to 4. And then jump back up on the increasing bandwagon. It's going to increase from what to what? 4 to 5. Good. So 4 to 5. Both of those are going to get parentheses. And then at 5, it starts decreasing again, so 5 to infinity. Nice, nice. There's a couple other points that I'll mention here while we're looking at this. And really, this is kind of like a heads up to what we're going to do at the end of this section, which is look at an old test question. So let me get back to my graph. So this point right here, right at where x equals 4, it's kind of a minimum point, right? It's lower than anything near it, but it's not the lowest that the graph gets at all together, right? So this is what's called a local min. So I'll label that as a local min, aka local minimum. Now this one over here, that's not a local minimum. What would that one be? What would you call that one? A local maximum. This one to the left of that is, well, you could call that a local max, but we actually have a little bit better term for that. You can think of it as an absolute maximum. Now, out of habit, you'll hear me call this global max. They're the same thing. Global max, global min, absolute max, absolute min. Basically, the graph does not get any higher than this. That's as high as it gets. Whereas this one's, the biggest thing going around, for nearby points, but it's not the biggest thing altogether. So that's why you have the difference there between global max / absolute max and local max. All right, nice. So I think we've knocked off those two. We good on those? Let's go down and work with example C. What's the domain? What's the range? Sketch the graph. So again, sticking with Desmos, or excuse me, sticking with our graphing calculator, I'm going to plug this one into our graphing calculator. I only want the graph for a limited amount of values here, right? I want the graph for values of x between -3 and 3. And that gives us a way to kind of get this graph, or get after this graph, without being too fancy with those piecewise type functions we did back in section 2.2. So let me enter that into my calculator. Let's see here. So I'm just going to delete some of these old values here. And I'm being lazy because I'm not clearing out the values up top, but we're going to use those coming up soon enough. So I want x squared minus 5. And where is it that I want to see that graph? Well, just between -3 and 3. So here's kind of my cheat for you on this. I'm going to enter -3 to 3 on the x-axis in my window, and then I'm letting my calculator do the rest of this work for me. What do I mean by that? What keys am I going to press to let my calculator set the rest of the window? Anyone? Zoom 0. Yeah, zoom 0. That's nice. Get a nice graph there. Fits pretty well. If you wanted to or needed to, you could hit the trace key. It'll put one in the middle of the graph, so you see it goes down to -5. But if you want to know, well, what's the value over here when x equals 3, just type in a 3. Now you're not going to see anything until you type in a number, but if you type the number 3, it'll appear here. Press enter, and it puts a point right over here, 3 and 4. So there you go. Now, if this is our graph, that's great. We can answer questions about that. You can look back at the video for section 2.2 and see how you do piecewise functions if you wanted to restrict the domain here. But personally, I like how this works out on Desmos. It's pretty easy. So if I wanted to graph this on Desmos and just limit myself to a little bit, here's how you do it. Type in y equals x squared minus 5, about a 5 here. And then I'm going to put in brackets my little condition. And that is -3 is less than or equal to x is less than or equal to 3. And that is my graph. And what's nice is that it just limits it to all that you need, which is right here. And you can see you got a minimum here and another point here at 3 and 4. In fact, let me just put that point there. 3, 4, and then we'll label it. Nice. So now that I got a nice graph of this, I can determine the domain and the range. So why don't you write it down? If you're watching this later at home, then try and beat me to the punch. Write down the domain and the range. I'll add in one more point to this graph. 0, -5. Okay. So Sean, can you help us out with the domain and range, please? What would the domain be?
For the domain, I got -3 to 3.
Good.
Put brackets on them.
Perfect. -3 to 3 in brackets. And for the range?
I got -5 to infinity. They bracket on the 5. Or negative.
Close. The graph actually stops at 4 though. So that's because of the condition that x's are just between -3 and 3. So the graph's going to stop here at 4. That's the maximum y height. So that would be the top end of the range. And we use a bracket there because the function actually does get to that point. All right. Thank you, sir. Let's keep going. Comments on that one? I mean, I like Desmos. It makes this a lot easier. We'll see that with, I think, example F as well. For now, let's move on to example D. I want us to look at the graph and find the domain. I also want us to compare the domain that we see to the domain that we kind of calculate. So for this graph, or for this function, what's the big concern that I might have in terms of the domain of f of x is the square root of x minus 2? What could go wrong? X could be what? What could go wrong here with values of x? Could I plug in, say, 6 into this function? What would happen if I plug in a 6? Oh, yes, actually 6 works okay. Duh, never mind. How about -2? Could I plug in -2? Would that work? You get the square root of -4. For the most part in this class, you're going to be dealing with real numbers and real valued functions, and that one's a problem. That one's a problem. So we can't just plug in anything in here because some values like x equals 0, well, that would give you the square root of -2. That's another problem. So at what point can I plug in values here? Well, 1 is greater than 0. 2. So let's take a look here. What you want to do is you want to guarantee that x minus 2 is greater than or equal to 0. You want this expression to be positive. So that's going to mean x is greater than or equal to 2. Those are the values of x that you want in your domain. So your domain is 2 to infinity. Does that line up with our graph? Let's find out. So I'm gonna do this one on Desmos. I think you can plug in a graph of square root of x minus 2 pretty easily, so I don't feel bad about not practicing that part with you. Let's clear out all this stuff. If you need to type in a square root, you can use the keypad on the bottom, or the other cool thing that I am always in the habit of doing is you type in SQRT, and it just gives you a square root, so kind of nice. X minus 2. Let's compare what we calculated with what we see in the graph. So are we seeing kind of the same thing? Does the domain that we're seeing visually correspond to what we calculated? Yeah. Starts at 2, goes out towards positive infinity. Nice. How about the range? What would be the range in this one? Joey, what would the range be?
I'd say it's definitely 2, and then to infinity would it be?
I think you're giving me the domain, which is the x values.
Oh,
We want the y values. So from lowest to highest in terms of the
0
y
to
values.
infinity.
There you go. Perfect. 0 to infinity. Thank you, sir. 0 to infinity. Yeah, because it starts at 0. You can see that point on our graph. And it goes up and up and up. And it goes up slowly because it's a square root function, but it does eventually get as high as you want. So it will eventually get to infinity. Nice.
Question.
Yes,
Is
Dave.
it greater than or equal to 2, or is it just greater than?
Greater than or equal to. Because you can take the square root of 0. If you put in a 2, 2 minus 2 is 0, square root of 0 is defined.
Yeah.
But it's anything less than 2, that's where you'd run into a problem. Appreciate the question. Thank you. All right, so E and F kind of go together. E is the kinder, gentler version of this. And then F's going to take a little bit of work for you. So we've got a couple functions here, F and G. We want to know, first of all, which one's bigger, f of x or g of x? It's going to be f of 0 or g of 0. My bad. Well, let's try and estimate the values for each of these. So what's it look like f of 0 equals? Yeah, it looks like it's about 3, right? So f of 0 is 3. How about g of 0? Who else? What's g of 0? Yeah, about 0.5. I'm not going to make you estimate, to the nearest hundredth or anything like that. So f of 0 is 3, and that's bigger than g of 0, which is 0.5. So that's the first one. That's kind of like your part A. Or first part. Maybe I should put part 1 there. How about the other part of this? At what values is f of x equal to g of x? So we'll call that part 2. F of x equals g of x. Now it says at what values? We're looking for the x coordinates here. We don't care about the y coordinates. I mean, they're kind of implied in here, but what are the x coordinates where those two functions are equal to each other? Nick?
Negative 2 and 2.
Is he right?
Yes.
Yes. Thank you, gentlemen. Negative 2 and 2. So I'll write it this way. Now, when you're putting in your answers, sometimes you have to list them with a comma between them. And I'm using curly brackets because that's the set of my answers. I'm not using parentheses because it's not a coordinate point. Now the last part of this is where is f of x bigger than g of x? Again, you're looking for values of x. This time we're looking for an interval or intervals. What values of x is f of x bigger than g of x? So where's the graph of f taller?
At 0.
At 0? Well, what else? Because there's a lot of other values, right? At 1, at
2 to 2.
0 to 2? Keep going?
-2 to 2.
-2 to 2, yeah, so all of those. So what you said, Nick, wasn't wrong, but we need to get all of them. So it's gonna be the third part of this one, so 1, 2, and 3 is gonna be -2 to 2. Thanks, Angel. Somebody else, brackets or parentheses? Yes.
Parentheses.
Parentheses, good. Because I want to know where it's greater than, not greater than or equal to. So you got to go past the point of intersection before it's greater than. So well done. Well done. Okay. We're going to play that same game again, except this time we're not going to be given quite so nice and neat of a function. This time we're going to be given, now let me turn over to this way. Example F here. We're going to be asked to find where does x cubed plus 4x squared equal -x squared plus 3x plus 5. And then we're going to want to find out, well, where is it actually bigger? So the first test is to plug in both of these expressions into your calculator. This one I'll plug into y1, this one I'll plug into y2. So let's plug those into your graphing calculator. I've already got mine plugged in. I'll just clear out this other stuff here. One of the problems you're going to have is deciding, well, where do I graph this? You know, these graphs probably aren't terribly familiar. I mean, even for me, I can't necessarily look at all these and say, oh, well, you should graph it in this window. You just don't know. So it's going to be a little bit of fooling around and feeling around. So does everyone got this plugged into their graphing calculator? For my homers, I hope you have your graphing calculator up and running. And if you don't, you can also follow along on Desmos. I will go back and do this on Desmos a little bit. But you can download an app for your TI-84 to your phone so you can practice with it there. And then at home or in class, you can borrow a calculator. So if I don't know where to graph it, kind of a decent place to start is Zoom 6, because that gives you the standard window. So Zoom 6, and okay, that's not a bad graph. The idea is, though, it gives you a place to start, and you want to adjust it a little bit. You want to fix it so that you can see what you need to see and do what you need to do. So we've practiced this before. What would be a criticism of this graph? How would you adjust it to make it better to suit our needs?
Zoom in.
Say again?
Zoom in.
Zoom in? Well, we're looking for where the graphs intersect. And right now I see that they intersect at 2 places. So do I want to zoom in? Is that going to show me where they intersect? I mean, I guess what I'm worried about is that maybe these 2 intersect, maybe they don't. Tough to know. So if I'm thinking that these might intersect, what can I do?
Zoom out and up a tiny bit to see if the blue graph continue, if it keeps going straight. Or if it,
I think this one is going to continue going up, so I think we're okay there. Noah's saying zoom out. Let me take a different approach. If these two graphs intersect, the red and the blue intersect, where are they going to intersect? Are they going to intersect higher or lower?
Lower.
Lower. So if they're going to intersect lower, then which of these do I need to adjust on my window? Yeah, the Y. In fact, I want Y min to be smaller. Now, I'm going to start with a little guess. It'd be negative 30. And for Y min, because that's going to graph this lower. I'm also going to do one other thing here. Well, I'll do it after I hit the graph key. Take a look at the Y-axis. Based on what I said earlier, what would you think my complaint would be? It's kind of busy there, isn't it? A lot going on. It's tough to see. I'd hate to have to count down here. Now, did I get to the point of intersection? No. So it means I got to go lower still on the Y-axis. It's not an exact art. You know, you just got to have to play with it, but it costs you literally nothing to go back and type in negative 50 here for Y min. I'm also going to do this for Y scale. Choose a bigger number.
10.
10? All right, I like 10. I was going to suggest 5 or 10 because both of those divide my Y min and Y max evenly. So let's go with 10 and bam. Now that we've gone down a little farther, now we see that there's 3 points of intersection, right? So what I'm going to do is I'm going to show you how to find this first one up here to the right, and then I want you to find the other two. And what I'll do is I'll walk around and try and check with you to make sure you're able to find these two, but stay with me on this. So to find this point of intersection, you're going to go to the calculate menu. So hit the second key, then the trace key. Second, and then trace. Does it look like there's something that's helpful at that point? Choice number 5. Now, choice number 5 works kind of funny. You're going to have to give it a guess as to that point of intersection for the blue curve, then for the red curve, and then one more just for good luck. So literally, you're going to have to press enter 3 times when you get close to this. Now, you got to get close to that point of intersection first, so I'm going to take the cursor and cursor to the right. And it doesn't have to be like perfectly close. You just want it reasonably close. How many times did I say you need to press enter? 3. 1 for the first one. Notice we're on the blue curve. So there's 1. Now we're on the red curve. There's 2. And now 1 just for good measure. 3. You should get exactly 1.1749721, etc. Are you able to get that on your graphing calculator? All right, so let's just take and round that off to the nearest hundredth. So about 1.17 right there. And what I want you to do at home, you to do in class, is find these other 2 points. So you got to go back and repeat this operation. But I can't emphasize enough that you want to end up pressing enter a total of 3 times. I had a good handful of students in my morning class who were just pressing it twice and their values were off. And you really shouldn't be off on this one. It should be able to give you some accuracy down to the nearest millionth or even less. So I'm going to walk around, find those other 2 points. If you have some problems, here's a good place to get some help. Nice. Perfect. Good job. to find the intersection, you're gonna run close to the point of intersection, press enter a total of 3 times. Sure. Alright, you need to get in whatever this 4x squared. You're gonna have to spend a lot of time on Google. You're gonna do this, or borrow my calculators, or use Desmos. I can't really help you out with that. No. Well, maybe if you needed to find that one, but you already found that one. When you press enter for the third time, it'll tell you your point of intersection. So if you want to go back and find this one, for instance, the second key, count, intersects, and this one, it's close to it. Well, maybe, so press enter to 3 times. 3. Okay. Okay, so let me practice this one more time with you using this example here on a graphing calculator. So I'll clear this out, clear that there. And if I want to find this, I'm going to go to the calculator or the intersect menu. So intersect, and then I want to get close to, it doesn't have to be right on top of it, just as long as it's close. Press enter, total of how many times? 3 times. 1, 2, 3. Okay, so negative 0.79. So negative 0.79, and then this ended up being negative 5.38. So those are your 3 answers up here for this first part, and that is, where do these intersect each other? So negative 5.38, negative 0.79, and 1.17. Beautiful. The next part of it, it says, well, where is the first function greater than the second function? So, all right, we're gonna have to think a little bit on that one. So basically, where is the blue graph taller than the red graph? If you look at what I've done, though, or if you look back at our work, we've already kind of given ourselves what we need because we know these points of intersection. So let's look at those here on this graph. So starting at negative 5.38 and until negative 0.79, this graph is bigger than this one. This one's our parabola. This one's on the right-hand side. We want to know where this one's bigger than this one. So right here in this interval. And then it dips below the parabola for just a little bit, and then back above. So I want these intervals. If you actually look back at the problem, it's asking for a greater than, not a, well, greater than or equal to. So that's going to mean I'm going to need to include the endpoints. So let's make these hollow dot, or solid dots here, here, and here. So what are the intervals going to look like then? Anyone? Jacqueline? What's this interval going to look like?
Negative 5 to,
Negative 5.38.
yeah, negative 5.38 to negative 7.79
Brackets or parentheses?
brackets.
Good. Brackets, thank you. Want to do this one as well?
Sure. And then bracket 1.17 to positive infinity.
Perfect. And infinity gets parentheses. Nice. Are you comfortable with that one? I kind of like that one as far as a good test question. All right. So I'm giving you two pretty much, you know, all right, expect these kind of problems. Example F, and then when we're going to get down to example H. Example H comes right off of an old exam.
Question.
Yeah, David.
Will that question be on the test?
Not this one exactly, but I'm telling you, I really like this kind of question. I mean, I think you should have some graphing calculator skills. Now, as far as the test is concerned, you can use Desmos if you download Desmos test mode. And that's going to make things a lot easier for you when it comes to solving these kinds of problems. So let me look back at this problem. And this is graphed on Desmos. And maybe you'll see part of why I like Desmos so much. Remember, we're going to have to find the points of intersection first, right? Are you ready for this? Keep a careful eye on me. Nothing up my sleeve. This is going to be really, really difficult. Want to find this point of intersection? I'll click here. Want to find this one? Oh, I'll click here. And one more. Done. Ooh, that's pretty cool. I really like that. And what's nice about this is that it removes the obstacle of having to deal with the technology, but you can still answer the question and show me that, oh yeah, I know where the red graph is taller than the blue graph. That's between negative 5.385 and negative 0.79, etc. You can still answer this question. It's still getting at the same things. It's just making it a lot easier with the technology for me and for you, really. So it's up to you. Let's continue with the next one down here. And we're going to deal with this graph right here. Graph of x to the fourth minus 4x squared. So repeating myself from earlier, if you think of the domain as being all values of x that you can put in here that aren't going to cause a problem, well, polynomials are never going to have a problem with a zero denominator or anything like that. So its domain is negative infinity to infinity, aka all real numbers. But the range is a little different. And again, the nice thing about the range is that you can find that from Desmos. You can actually find it from your graphing calculator as well. It's just a little bit more of a pain. Maybe I should show that to you as well. But let's take a look at it on Desmos first. So on Desmos, here's all I got to do to find these minimums. Now, if you're keeping up with what I said about this earlier, these are absolute minimums. The graph just doesn't get any farther below these numbers than it is right here. So as far as the range is concerned, from bottom to top, lowest to highest, what would the range be, Ava? What would you suggest here for the range? So from lowest to highest, range is which values, the y or the x's? All right, the y values, good. So the lowest y value you see here is at what? I got one down here at negative 4. So from negative 4 to infinity, is that negative 4 going to get a bracket or parenthesis? Good. So negative 4 to infinity. As far as where is it increasing and decreasing? Again, off of Desmos, you can get these points, negative 1.414 and 1.414. So as far as decreasing is concerned, you're going to start decreasing way out here at negative infinity. So way out there until you get to this point. And then it starts increasing. it's going to start increasing and keep on increasing until you get to where? 0. And then it starts decreasing again until you get to this number. Now in calculus, you'll actually learn to find these numbers exactly. You might not recognize 1.414, but it's really the square root of 2. So see if you can't write down the intervals where it's increasing and decreasing. And I am going to show you one last trick in terms of your graphing calculator, which might mean we're going to have to sacrifice a little bit of time for example H. Maybe I'll just do example H for you, with you. But as far as decreasing is concerned, it's decreasing from negative infinity to negative 1.414 union 0 to 1.414. That's where it's decreasing. And as far as increasing, it's just going to be filling in the gaps there. Increasing a negative 1.414. It should be a comma. I think I'm out of the fun stuff. Yep. So 1.414. Yeah, negative 1.414 to 0, union 1.414 to infinity. So that's where it's increasing. What if you don't have decimals available to find that minimum point? That's a good question. That's a real good question. Again, your calculator can help you out. So let's put that into our graphing calculator. Let me clear out this stuff. Clear that out. And let's put in x to the 4th minus 4x squared. X to the 4th minus 4x squared. I'm going to give you a chance to put that into your calculator and then try and follow along with me. So x to the 4th raised to the 4th, and then get out of the exponent, minus 4x squared, square key for me. Now go down and clear that one out. Clear key, good. Let's set up our window. So let's set up our window from, I don't know, -3 to 3. That should be fine. Doesn't have to be too dramatic. So -3 to 3 on the window. So at the window, type in -3 to 3. Probably need to adjust things in the y direction, but I don't really feel like it, so I'm just going to cheat. We've already graphed this on Desmos. Let's set our y minimum to -5, so it's a little bit below our graph at a maximum of, say, 3. And I better change y scale to be 1 or something smaller than these numbers. So looking pretty good there. And there's our graph. Now, if you're looking at this and asked to find where the graph changes from decreasing to increasing or vice versa, then you need to be able to find these points. So this is a minimum point. So let me show you how to find a minimum point here. You're going to hit the second key, then the calculate key. Just kind of like we did earlier. Does there look like there's something useful on this menu? Minimum. Yeah, so pick the third one down. Now the way the minimum works is you have to give it an area where to look. You have to give it something to the left of your minimum and something to the right of your minimum. And say, all right, look for the minimum in this interval. So you can take your cursor and cursor someplace to the left of your minimum. So get someplace to the left of this and then press the enter key. It doesn't have to be the same as mine. And now it wants someplace to the right. So, okay, let's go back and go to the right of that and press enter. It's gonna look for a minimum in that interval. And kind of like what we did with our previous one, where we're trying to find points of intersection, it wants an initial guess. Just press enter, make the calculator work for its money. So there you go. There's its minimum. Let me show that to you once again. So calculate menu. So hit the second key, then the calculate menu. So hit the second key and then trace. Minimum is number 3. This time, let's find the minimum over here. I'll show you a little trick. If you're asking for a left bound, instead of using the cursor, you can just type in a number. Like, okay, I'm gonna type in the number 1. All right, that's my left bound. And then I wanna type in something else. I'll type in a 2. That's my right bound. Make sure that the minimum is in there someplace. Press enter one more time, and it should pop to your minimum. All right, looking good there. We don't have time for me to let you work on the old exam part of this stuff, but this is a good example of questions that I like. So I would definitely take time to work on this. Now, it doesn't really show up as well on a handout as I might like. My apologies there. But this gives you everything you need in order to figure out where is it increasing, where is it decreasing, minimum, maximum, inflection points, all that good stuff. I think I've got some answers here for you. If I can dig it out real quick. Yeah. So the domain, you should be able to pick that up. That's just the x values that goes from -4 to 4. The range is going to be the y values. So let me highlight some of the y values here for us. The y values are going to go from this low value down here at -38.25 up here to 6.67. So that's going to be your range. So if you're looking to see what that would be, that's these values down here, -4 to 4, and then -38.25 to 6.67. Where is it increasing and decreasing? Well, it's increasing between -3 and -1. Keep in mind that these are places on the x-axis. So -3 to -1. Let's just double check that. I'm feeling uneasy about that. Yeah, here we go. So -3 to -1. That's where it's increasing. So right here in this interval. And then it's increasing again in this interval for x, 3 to 4. It's decreasing in these other intervals. WebAssign is going to include -4 with a bracket as part of where it's decreasing. It's also going to include +4 in a bracket where it's increasing. So as far as increasing and decreasing is concerned, it's going to look like this, -3 to -1, and then 3 to 4 with a bracket. Decreasing, -4 to 3, 4 gets a bracket, 3 gets a parenthesis. And then -3 to 1. Local minimums, I would expect 2. Now really, one of these, that one's a local min. This one's actually an absolute min because the function doesn't get any lower than that. So if I ask you for the local mins and you put negative, say, about 0.33 and -38.25, I'd be fine with that. That'd be fine for the local mins, although actually that one's a absolute min. For the local max, really, I see one local max, and that'd be right here. Now I specified that I wanted the y coordinate for the local max. I could ask for the x coordinate, I could ask for the y coordinate. Please pay attention. It's not a perfect 5. It's a little bit less than 5. So you gave me 4.8, 4.7, 4.9, something. As long as it's not a 5, I'll probably be pretty happy. But you should notice that it's below 5. The other possibilities for local max I would take would be this one right here and this one over, this one over here. That is a local max in the sense that it's bigger than anything near it. This one's actually a global max, but again, I'll take it. So throwing in those values, I get 4.9, 6.67, and negative 22. How do I know that this is a function? What do your functions do? You're 2 questions away from getting out of here. What do your functions do? How do I test if it's a function? Hattie?
Vertical line test.
Vertical line test, yes, all right, I pushed the right button for somebody. Vertical line test, it passes the vertical line test. No vertical line intersects the graph more than once. So it is a function, and the justification is that it passes the vertical line test. Last but not least, where is f of x greater than or equal to 0? So I specify that I want intervals along the x-axis. Let's go back here. Greater than or equal to 0. Let's get rid of some of this. Greater than or equal to 0 is going to be here, -4 to about 3.5. And then where else? About,
2.
yeah, 2.25-ish. Yeah, 2.3. I'll give you some slack to 0. And that's it, right? Just those 2 intervals. So here's what I wrote for mine. -4 to -3.5 and -2.3 to 0. I put brackets because the problem asks you for greater than or equal to. So I'll include the endpoints as well.
Do we have a union in there?
A union in here would be most welcome and appropriate. Yep. Awesome. That'll do it. That'll do it. Have yourself a good afternoon and good weekend.